I'd like to take you through the steps that I often use when I'm solving optimization problems. And when we're solving optimization problems, basically what we're doing is we're solving problems that involve finding a maximum or a minimum value for some kind of quantity. And probably the most complicated part of coming up with solutions to optimization problems is first of all coming up with an equation to represent it. So I always start off, first of all, drawing myself a picture if possible, and then using formulas or equations that I know to see if I can model what's going on in the picture with an equation. Now, to know what equation I need to come up with, I always look to see what the question is asking me to either maximize or minimize, because that quantity is a quantity that I want to ultimately represent with a formula or an equation. If it's possible, I want to try to write that formula or equation so that it is its dependent variable, or its y value, the value that we're trying to maximize or minimize, is written explicitly in terms of the independent variable, independent variable x. And often you'll have formulas or equations that have more than two variables, so more than an x and a y. They might have, like for example, if we're looking at volume of a prism, it might have the length, the width, and the height. Or if you're looking at surface area of something, it might involve a height and a radius. So in those cases, what we want to do is we want to use other information in the problem to see if we can use that information to help us eliminate any extra variables so that we're just working with our x and our y. So once we've done that part, that's the hard part. And then the process becomes a little bit more straightforward. So once we've come up with our equation of the variable that we want to maximize or minimize, then we're going to find the derivative of that equation to help us find the critical numbers. So remember, to find critical numbers, we find the derivative, we set the derivative equal to 0, and then we solve for the independent or x values. Once we have found our critical numbers, we want to see if our critical numbers are in fact maximum or minimum values. And there's two ways we can do this. So the first option is to use the first derivative test. So you'll remember that if the derivative of a function is positive, then that means that the original function is going up, or it's increasing. If the derivative of a function is negative, that means the original function is decreasing or falling. And if the derivative of a function is 0, we know that's a possible maximum or minimum because the curve has a rate of change of 0, so it's not neither increasing nor decreasing. So what we can do is, if we know a critical number, we can see if it's a maximum or minimum by choosing values just to the left and to the right of it, putting them into the derivative, see if they're increasing or decreasing, and then using that to tell whether or not the critical number is going to be at a maximum or a minimum. The second method, which I usually find a little bit quicker, depending, of course, on the equation that we're working with, is to use the second derivative test. So if we find the second derivative, if you'll recall, tells you about concavity. So if I sub in my critical number into the second derivative and I generate a positive number, well, I know that a positive second derivative means that my original function is going to be concave up, and that means that my critical number must be a minimum in order for it to be concave up. If I sub in my critical number into the second derivative and I get a negative value, well, that means that the original function is concave down, and that means that that critical number must be a maximum in order for that to occur. And finally, if I sub my critical number into my second derivative and I get a 0, well, that's just a possible point of inflection where the concavity changes, so it's neither a maximum nor a minimum, and I probably have to do some more analysis. So once you've confirmed that the critical number that you found do in fact represent the numbers that you're trying to find in the problem, you will also want to just double check any endpoints. So if you have restrictions on your domain, then you'll always want to check to see if the lowest value of your domain and the highest value of your domain will generate either a higher or lower value, depending on what you're trying to find, that your critical number generates, just because they won't show up in your analysis of the derivative, but they might be actually the maximum or minimum point for a situation based on restrictions on the domain. So you always want to check the endpoints if necessary. And then finally, once you have done all of your analysis and you're confident that your critical numbers are correct and that you have found the maximum or minimum values, then you want to write a conclusion to summarize what you have found. So hopefully this helps just give you a process for solving optimization problems. And we've got lots of problems for you to practice on to take you through this process and get a really good handle on how to solve these types of problems.